Attention, science explorers. Have you ever heard of quantum computers? People say they will change the world completely in the next few decades by helping scientists discover more about the quantum world, help them create new medicines, calculate equations that'll take hundreds of billions of years to solve in just 1 second, improve artificial intelligence, and more. Today we'll take a small trip to the different types of the quantum computer. Here we go. The first type is the superconducting quantum computer. This is a type of quantum computer that works by bringing the temperature down to the coldest temperature possible, just a little bit above absolute zero. This makes the circuits quantum mechanical, meaning they become coherent, so the superposition of electrons is not disturbed. Superposition is basically when a quantum particle exists in multiple states at the same time. IBM's Eagle processor, Google's Sycamore, and more other quantum computers are superconducting quantum computers. The next is the ion trap quantum computer. These computers hang ions in a trap consisting of a series of electric and magnetic fields and make these ions vibrate as coherent qubits. For example, if the electron axis spins up, then the state is a signal of 0. If it spins down, it is a signal of 1. Then microwave or laser beams can hit these ions, flipping them and causing them to change states, therefore acting like a processor that flips transistors between 1 and 0 states. The third is a photonic quantum computer, which uses the fact that light can vibrate in different directions. For example, a light beam might be vibrating vertically up and down, or perhaps sideways, so the number 0 or 1 can be represented by light vibrating in different directions. One of the most famous photonic quantum computers, named Juzong, was developed in China, and that computer was the second computer in the world to reach quantum supremacy, which is a point where it is impossible for a digital computer to do the same thing. Another one is the silicon photonic quantum computer. It uses silicon to create optical components. This is done by carving tiny channels in silicon wafers, which allows light to be guided through the chip. PsiQuantum, a young company, takes an approach of creating these silicon photonic computers that are based on their fusion-based quantum computing, or FBQC, architecture. FBQC uses a combination of optical and electronic components to create a scalable quantum computer that never breaks down. And finally, the topological quantum computer. It is a design by Microsoft and it uses topology. Imagine a donut with a big hole in the middle, and you try to squeeze it or throw it or twist it. But unless you cut the donut in half, the hole will be there, right? Like this, topology studies shapes that can never be broken down, no matter how hard you try. With this topological design, the system will remain stable even at room temperature. In other words, it would be extremely revolutionary if this design actually works. In 2018, physicists announced that they had discovered a material with these properties, something called the indium antimonide nanowires. Indium. Just as it looked like a game-changing discovery was made, it was soon revealed that the results they got were inaccurate. However, the idea is still being studied, and there are other possible options for topological objects, such as anions. Okay, there you have it, the different types of quantum computers unveiled. Keep in mind that this is just the main types, and there are more that I didn't talk about today. I can't wait to see what the future of quantum computing will be like. Let's keep on exploring together. Now, let us return to our daily lives.